Alright, so today we're going to be going over adding and subtracting vectors. So there's three things to know here, which is first is the vector rule. So let's say we have vector A going up to the right a little bit, and then vector B going south to the east a little bit. In order to find what a vector A plus vector B equals, you want to connect the vectors together, and then connect the start of the first vector to the end of the second vector, which in this case is vector C. And that would give you your addition value of the vector. And now when we write out a lot of the vectors in like numerical components, we would break up a vector into an x component, which would be expressed by this, and then a y component, which would be expressed by this. So let's say we have vector A, which goes 2 to the right, which would be expressed like that, and then it goes 3 down, which is expressed by the negative sign, and then 3 units down. And let's say you have a vector and you want to find the degree symbol of it. In order to find the degree symbol given your x and y components, if you remember from tangent in calculus, tangent is equal to opposite over adjacent. In this case, you would just do tan -1 or arctan, and then you do arctan j over, or arctan opposite over adjacent, and that would give you the degrees, which is in this case theta. Alright, so let's start with number one. So number one is trace the vectors in this figure onto your paper, then find a plus b and then vector a minus b. So we're going to do a plus b first. So a plus b would be, let's use the vector rule. So it would be, this is going to be a, and then vector b is going to be to the left. So we're going to connect that to the left right there. And then vector c, which is going to be our, what it's equal to. If you remember, we connect the end of the first vector to the end of the second, or the start of the first to the end of the second, in which vector c would be like that. So that would be equal to our c vector. And that is our answer for that. And then for vector a minus vector b, what we're going to do is do the same thing with the vector rule, except instead of vector b being positive, now it's negative, which means when the vector b is negative, it's going to point the opposite way. It's going to be negative of what it's doing. So now we're going to use the vector rule using these new vectors. That's negative b vector. So we're going to plot vector a again right there. And then vector b this time is going southeast. So it would go like that. And now we connect the start of the first to the end of the second, which is going to be line going like that. And that is going to be our c vector. So that is going to be our c vector, which is going to be our a vector minus b vector is c vector. So that is our answer there. Alright, so now we're going to move on to 3a. So what are the x and y components of vector e shown in the figure in terms of angle theta and the magnitude e? So we're going to be taking a look at this vector right here and then theta, which is this degrees. So we're going to have to use some trig functions here because, we're dealing with some degrees and we want to find out the x and y components. So let's figure out the x component first. So the x component is going to be this right here. So we have vector e and we want to find out this line. What trig function would work with the opposite and the hypotenuse? So if you remember from calc, pre-calc, and I guess trigonometry as well, the sine function works with opposite and hypotenuse. So what we do is we would just have sine theta. Sine theta would give us this line right here, which is going to be our x component, or I. And then now we want to find the y component, which is going to be dealing with this line that goes down here. So this line that goes down here is going to be our adjacent, the theta. Adjacent and then hypotenuse is what we know. So do you guys know what trig functions deals with adjacent and hypotenuse? Now, if you remember, that is cosine. So what we do here is we're going to have cosine theta. Now, cosine can't be positive because this is going downward. This y value is in the negative range, so cosine has to be negative here. But sine is positive because it's to the right of the y-axis. So sine theta minus cosine theta is going to be your final answer. Alright, so let's take a look at number 4. So number 4 is a velocity vector of 40 degrees below the positive x-axis has a y component of negative 10. What is the value of its x component? So let's draw out the vector right here. So we're going to have this vector, and this is 40 degrees. We know that. And this y component, which is going to be the y value of the vector, is going to be negative 10 meters per second. But we don't know the x component, which is going to be that right there. So we don't know that. Now, we want to also use trig functions here in order to find out the x component. So we have the opposite. We're trying to find the adjacent. So ideally, we do opposite over adjacent or adjacent over opposite. But if you remember from trigonometry, adjacent over opposite is cotangent. But opposite over adjacent is tangent, and tangent, it's much easier to use, so we won't use adjacent over opposite. So opposite over adjacent is equal to tan. So now we're going to plug stuff in. So we'll have tan 40 degrees is equal to opposite, which is negative 10, over adjacent. And we don't know adjacent, that's unknown. So now we just solved for adjacent, or rather this could just be x. So in order to solve for x, we could switch x and tan 40 degrees. So we're gonna, if we rewrite this and set it equal to x, we're gonna have negative 10 over tan 40. And negative 10 over tan 40 gives you an x value of negative 11.92. So our x component here would be negative 11.92. And that is our answer here. And the answer is actually positive. So it's positive 11.92 or positive 12. And that is because the question is representing to positive x-axis. So it's meaning to the right of the y-axis, basically. And to the right of the y-axis, everything is positive, or the x values is positive. So the answer really would be just x is equal to 11.92, actually. Alright, so I want you guys to try number 2 out. So essentially, for this, you're just going to use the vector rule to find vector c. So you could pause the video and try that out. Alright, so let's take a look at number 2. So number 2 is trace the vectors in to this figure onto your paper and then find a plus b and a minus b. So let's take a look at vector a plus vector b. So again, we're going to use the vector rule, in which vector a is going to be that, and then vector b is going to be also in the same direction a little bit, but a little bit more east. Now we just connect the start of the first vector to the end of the second, in which our vector c is going to be going up like that. So that is going to be our vector c. It's going to be pointing northeast. And now vector a minus vector b. So again, we're going to use the vector rule here. So we're going to draw A. A is going to be positive, so it's going to be facing up. B, though, since B is negative, it's going to be going the complete opposite way. So we're going to have to draw B like, it's going to go like that. And now we need to connect the start of the first vector to the end of the second, in which that's going to be a little bit like that. And the reason why it's going so far west is because vector B is longer than vector A. So it has a bigger magnitude. So that is going to be our vector C. Our vector C is going to go slightly south, but to the west. Alright, so let's take a look at number 6. So number 6 is draw each of the following vectors and find its xy components. So we're going to look at A first. So A is vector A. We could draw it out. So vector A is to the negative x direction, 3.5 meters per second squared. Now, to find the xy components, we are given that it's just in negative x direction, which means that it's not going to have any y component. So vector A would be equal to negative 3.5 I, and then that would just be plus 0j. or plus or minus 0j, that would mean that all the force, or rather the vector, goes 3.5 to the left. And you could even use trig functions and you would get the same thing. But now let's look at vector v. So vector v, or velocity vector even, is going to be 440 meters per second, 30 degrees below the positive x-axis. So we're going to have it go at something like that. So this is going to be 30 degrees, and this is going to be going at 440 meters per second. So think of the hypotenuse as equal to 440. And now we need to find this, which would be our y component, or rather this symbol, and then which would be our x component. So in order to find our y component, what could we do? We know the hypotenuse, which is 440, and we know the degrees. So vector v, we could set that equal to, in order to find the x component, knowing 30 degrees and 440, we would have to use cosine here because the x component is adjacent and we know the hypotenuse. So we're going to have it's going to be, we could write it out here. We could write it cosine 30 is equal to I over 440. And now our x component is going to be equal to 440 cosine 30. And we're going to simplify soon. And then that's going to be added on to, and that's going to be I. I'm showing that that's our x component, and that's going to be x, actually, instead of I. But now, to find our y component, we're going to have to use sine, because we're dealing with opposite and then hypotenuse, because y is in the opposite notation here. So y is going to be sine 30 is equal to, let's say, x over 440. Because that's opposite over hypotenuse, which means x is going to be equal to 440 times sine. So our y component is going to be 440 sine 30 degrees. And we're going to write j next to it. And if you simplify everything, we're going to have vector v equal to 381 rather 1, or we could just leave it to 381 plus 220. And that is going to be, we write our I and then j next to it, showing the x and y component, and that is going to be how the answer is going to be written. And now let's take a look at r. So we're going to have to find the y components of vector r. So real quick, let's delete this out of the way. And let's see vector r. So vector r is going to be 40 degrees above the positive x-axis. So it's going to look something like that. Vector r and then 40 degrees. And we're going to have 12 meters. So vector r is 12 meters. So we could kind of think of the hypotenuse as 12 meters. Now we want to find this right here. So that's going to be our y component, or rather j. And then this is going to be our x component. So now we're going to use trig functions again, like the really similar method to find it out. So we're going to have vector r is going to be equal to, we know the hypotenuse and we know the degrees. So for the y component, we're going to use sine here, and the x, we're going to use cosine. So for the x component, we're going to have cosine 40 is equal to x over 12, in which x, or rather the x component, is going to be equal to cosine 40 times 12. So 12 times cosine 40, and that's going to be added onto the y component. I drew the x component symbol right there. And then the y component is going to be represented by sine 40 is going to be equal to x over 12, in which the y component is equal to 12 times sine 40. So 12 times sine 40 and the y component. And now if you plug that all into a calculator, you would get 9.2 for the x component, and then you would get 7.71, or rather just 7.7 if you round it, for the y component. And that would be your final answer.